We are studying thermodynamics. Let me just adjust this. We are studying thermodynamics, and one of the topics we've got to look at is thermometers. What sort of thermometer do you use, and how do we measure temperature using a thermometer anyway? You just pick up a thermometer and you read what it says, but what's the physics behind all this? Well, there are various physical quantities that change with temperature. One of those might be volume. So with volume, you can get an in-glass thermometer like this with a bulb with a certain volume of liquid, whether it's alcohol or mercury, and at a certain temperature there will be a certain volume, so it will reach a certain height on the thermometer, and with an increase in temperature there will be an increase in volume and it will rise higher and it will then go up to there. So this change in length reflects the change in volume, and the change in volume will be proportional to a change in temperature, so you can measure temperature that way. But not only volume, but perhaps electrical resistance of a wire can be used, or the pressure of a gas at constant volume. If you've got a container with gas in it and you've got a way to measure the pressure, and you can keep the volume constant, then the change in pressure will be proportional to the change in temperature. Now this is only true when we think of thermodynamic temperature, not temperature measured in degrees Celsius. But anyway, the other one would be the thermocouple thermometer. And with a thermocouple, this is the EMF at a junction, the EMF at a junction between two different metals. So the size of the EMF will be proportional to the temperature. So really what we're talking about is we're saying the temperature is equal to, it's going to be a ratio. On the bottom line we've got the quantity, whether it's length or volume or pressure or EMF or resistance, whatever you're talking about. The quantity at 100 degrees Celsius, or at the boiling point of water, minus that quantity at 0 degrees Celsius, or at the freezing point of water. That's on the bottom line. Over the top we've got that quantity at temperature T minus x0, which is again, it's the quantity at 0 degrees Celsius or at freezing point of water. So this is the quantity at boiling point of water, the quantity at freezing point of water, and this is the quantity at temperature T, which there's no point in writing anything there, but it's the quantity at temperature T. So this is what we use to calculate temperature. So it's a simple fraction really. So at 50 degrees Celsius, this quantity here is going to be halfway in between that and that, which means the numerator here will be half the size of the denominator. Of course we then have to multiply this by 100. We multiply this by 100, so that gives us a scale between 0 and 100, which is what we want for the Celsius scale. So the quantity at the boiling point of water minus that quantity, the same quantity at the freezing point, maybe it's volume, and the volume changes by a certain amount. Well, at 50 degrees Celsius it will change by half of that amount, which will give you 0.5 times 100, which gives you 50 degrees Celsius. That's the equation we use. Now, there are various different types of thermometers, and they all have their good points and their bad points. And to understand that, which you need to look in your notes, and there in your notes there's a heading that says types of thermometer. This page. It goes through the mercury in glass thermometers, the constant volume gas thermometers, the platinum resistance thermometers, the thermocouple, and a couple of other types. The thermocouple is the one you need to have a bit of understanding about. It's got a wide range, it's accurate, it's robust, it's compact, and it's used in industry. It's very useful when temperatures are changing rapidly, which is fairly important, and it can measure temperature at a point, which is also really good. Mercury in glass thermometers are good if you have got time to wait. They're portable, they can be broken quite easily. They're good for use in some circumstances. The platinum resistance thermometers, very accurate. They don't change quickly, so you have to wait. So if you're wanting to measure change in temperature over a short period of time, then they're no use. Good for small, steady temperature differences. Okay, so that's thermometers. We'll be back with more on thermal physics shortly.